Hello everybody, and welcome to another geometry lesson. Before we get started, you may hear my voice, it's a little gravelly today, so I apologize, but I'm going to try and go through lesson 5.2 relatively quickly. So, section 5.2 is all about congruent polygons, proving that two shapes are in fact congruent to each other. And we're greeted with a couple of very familiar looking definitions. That's right. We've got reflexive, symmetric, and transitive properties of triangle congruence this time. So, if you want to say that a certain triangle, maybe triangle ABC, is congruent to itself, that's what the reflexive property says. It says that one triangle is congruent to itself. On the other hand, the symmetric property. The symmetric property always says if you have some triangle congruent to another one, so let's say ABC is congruent to DEF, then you're always allowed to flip these congruent statements backwards if you need to. So instead of ABC being congruent to DEF, then DEF could also be congruent to ABC. Finally, we have the transitive property of triangle congruence. If you have some triangle, ABC, and you know that it's congruent to some triangle DEF, but DEF is also congruent to some other triangle. This time I'll call it triangle GHI. Then the transitive property says if triangle A equals triangle B equals triangle C, then A equals C, or the first triangle is congruent to the last triangle. There we go. So as we're going through showing that triangles are congruent, keep these in mind. We will be using them occasionally. Before we go on to the next definition, I want to talk a little bit about identifying these congruent triangles as well. So, when we say that two triangles are congruent, two triangles are said to be congruent if and only if each corresponding side and corresponding angle is congruent. In short, this means if you want to show that some triangle is congruent to some second triangle, for right now, you will need to show that every single side pairs up with a side on the other triangle, that every single angle pairs up with every angle on the other triangle. Let me do a brief example here. So, down below, we see that we have a couple of triangles. If I'm trying to show that these two triangles are congruent, I need to match up the angles and sides that are congruent to each other. Thankfully, in this triangle, we are actually told that certain things are congruent, like A and D, for instance. Since A and D have the same congruence tick mark, A is congruent to D. We can do the same things for B and E. So B has these three marks, and so B is congruent to E. And the same thing with C and F. Both of these angles have two tick marks. So sometimes we are just told that some things are congruent. Now, here's the kicker though. When you are trying to make a congruence statement, you are stating that something is always going to be congruent to something else. A is always going to be paired with D. B is always going to be paired with E, etc., etc. So look what we did with these corresponding sides. If I asked, what side does side AB correspond to? Notice the order that I said the other side should be. A is always congruent to D, according to this statement we made here. So A and D should both be in the same spot in the congruent statements. Similarly, we said that B is congruent to E, so in our congruent statement, B and E are both in the second spot. The order does matter. Now, you could have also said BA is congruent to something. This is totally fine. But watch your order. What's B congruent to? E. So you would have to have E first to match this. What's A congruent to? D. So you would have to have D second to match that. That is how you make congruent statements with sides. So every time there's a letter B, the letter E is on the opposite side of the statement. Every time there's a letter C, F is on the other side of the statement. And as we already showed, every time there's an A, D is on the other side of the statement. So in the example above, the listed angles match the order of the sides. And both must match the congruence statement. When we ask for a congruent statement, we want to state that two triangles are the same. So in this case, what would ABC be congruent to? Well, A is congruent to D, B is congruent to E, and C is congruent to F. So ABC is congruent to DEF. Very, very nice. Let's flip over to the next exercise to see if we can practice this. So I want you to pause the video here and see if you can write congruent statements for these two triangles. In order to do this, you'll need to do just what we did in the other example. Find all the pairs of congruent angles. Use that to help you make a list of congruent sides. Then make your final congruent statement. Pause the video and try it out. All right, folks. So when we match up these angles, we can see that L is congruent to R, J is congruent to T, K is congruent to S, right? Well, my recommendation is when you're putting together your sides, first note that the side L to J will be this left side here. I'm going to start by just putting in those two letters and seeing what they match up with. L matches to R, J matches to T. So just by knowing that LJ is a side here, and knowing that L is congruent to R, J is congruent to T, I can finish the statement. I like to go down the list and just pair things off. So I did L and J. Now I'm going to check if J and K is a side. Yep, JK is absolutely a side. So I will write J and then K and check my list of angles to see what it pairs with. J pairs with T once again. K pairs with S. So line segment JK is congruent to line segment TS. Don't forget the line segment symbol. The last pair, I usually take the last letter and pair it with the first one. So KL is congruent to, well, K is congruent to S, and L is congruent to R. So side KL is congruent to line segment SR. When it comes to making the final statement, the letters order doesn't really matter as much as long as it matches on both sides. So I could call this triangle LJK, and that's totally fine as long as I pair it with what the other side says, RTS. And that's how we write congruent statements. Very nice, everyone. Let's take a look at example 2. So in example 2, we are trying to show that ABD is congruent to CDB. Now, as we look at this, remember what we need in order to prove that two triangles are congruent. In order for two triangles to be congruent, we need all the sides and all the angles to match up. It's usually a good bet, if you're a little bit stuck, to list off what sides and angles you do know. So that's what we're going to do here. I'm going to list off all the angles that I do know are congruent, and all the sides that I do know are congruent. So let's start here. A is congruent to C. Easy enough. We also have a second pair of congruence markings, but there's a bit of an issue. We know that this set of congruence markings is congruent to this set of congruence markings, but what do we call this angle up here? Now you might be tempted to call it angle B, but this is also angle B, and one letter cannot have two angles associated with it. So as a brief reminder, we named these angles using 3 letters. Again, if you have two angles that share a vertex point, you name it using 3 letters. So if I'm talking about this yellow shaded angle here, I'm going to go from A to B to D. A, B, D is the name of the angle, with the vertex B always being in the middle. So I'm going to call this angle A, B, D. And again, you know, we're really talking about the angle at point B because B is in the middle. When we end up pairing up certain letters with certain sides, this is going to refer to angle B. So let's keep going. A is automatically congruent to C. So we know that we can automatically put angle C something something. Well, if we went from A to B to D, and we know our new statement has to start with C, how do you start with C and end up going along the same route? C pairs with A, D pairs with B, and B pairs with D. So CDB is the name of this angle. CDB. It's a little confusing, but if you remove the colors other than blue in this statement, we have B is congruent to D. And it also makes sense that D is congruent to B. That's why in the green we have just enough space to talk about the last angles. But the problem is, we don't know that the last angles are congruent. We don't have congruency markings. So here's my question. Is there any other marking in this problem that would tell us the green angles are congruent? The answer is yes, but in an unlikely place. We have 2 parallel tick markings. Okay, Mr. Strager, so what? Well, watch what happens when I magically tilt my paper in this direction and, I don't know, let's say I extend out these lines a little bit. If I were to extend out these lines, maybe our unit 3 senses are tingling a little bit. Folks, the green angles here are angles that are on this middle transversal. And these are parallel lines. So what do we know about parallel lines that both intersect the same transversal? Well, they cause alternate interior angles. Which means that, yes, this angle is congruent to this angle. Let's list it off first and then explain it. So, once again, you can name these in any order you like. I'm going to start with A, then go to D, then go to B. As long as D is in the middle, the order doesn't super matter. So A, D, B would be the name of that green angle here, marked by the fact that green is in the middle, is congruent to angle. Well, again, if we follow the same route, A is congruent to C, so we know we're starting with C. And we know from the last statement that D and B are congruent. So C, B, D. Essentially, we've just proved we already know that B and D are in the same spot. So these are the three angles. Again, imagine these as just being angles A, B, and D, and these three angles as being C, D, and B. How do we know that these green angles are congruent? Due to the alternate interior angles theorem. Very nice. When it comes time to list off the sides, this may actually be less cluttered. Again, I'm just going to go down the line. A, B is one of the sides here. So what's A congruent to and what's B congruent to? Well, A is congruent to C, according to our first statement, and B is congruent to D, according to our second statement. Does it look like it matches? A, B, and C, D? A, B is up on the top, C, D is on the bottom. They match. You could go through and do something similar with all of the other sides as well. So for instance, I'm going to go and next talk about line segment BD being congruent to line segment DB. The problem is we don't actually have markings to show that. But this brings up an excellent point. Why would BD be congruent to DB? Well, in our heads we think, well, duh, BD and DB are the same line segment. But then it should click. There is a property that tells us that if something is congruent to itself, then it works. That's right, folks. We have finally used the reflexive property. Not just the reflexive property, but the reflexive property of segment congruence. The rule is that something is congruent to itself, and since BD and DB are the same line, it works. Finally, if I'm matching up all the letters, DA is this side here, BC is the opposite side over there. So, we have proved that these two triangles are congruent, since all angles and all sides are congruent. The reasoning that we would give for this is as follows. All corresponding parts are congruent. And for right now, that's how we are going to be proving that triangles are congruent. Won't always be the case. We'll have some quicker ways of doing it too. So, proofs involving congruent triangles can often be easier than others. Think of it like a checklist. You know what you have to prove. You have to prove that 3 pairs of angles and 3 pairs of sides are the same. So, use the given information, because the given will usually fill out most of this checklist. And a highlighter can also help. Before we do this last proof, I think it warrants talking about the final theorem of today, the third angles theorem. If 2 angles correspond on 2 triangles and are congruent, then the third angles are also congruent. This is the third angle theorem. It says if you have 2 triangles and you already know that 2 of the angles on each match up, then according to the third angles theorem, by default, the third angle has to match up. So now we've shortened our checklist down. We don't need to prove that 3 sets of sides and 3 sets of angles are congruent. We need to show that 3 sets of sides and 2 sets of angles are congruent. Once we find two of them that are congruent, we can prove the third one using the third angles theorem. That's going to help us a lot in this example down here. So pause the video here. I want you to try and see if you can use this checklist to see what's missing and fill in the proof. Pause the video and give it a shot. Hopefully you've been able to give this a good, honest try. Let's see what we've got. So, in terms of sides, we already know that two pairs of sides are congruent. AD is the one on top and bottom here. DC is the one that's here. It's congruent to BA right over here. And we need to prove the final side, AC, is congruent to, well, let's take a look at the statements. A is congruent to C, and C is congruent to A. Oh, we are just trying to prove that AC is congruent to CA. But we also notice that the letters match in the statement. AC flipped around is CA. So from the last example, we know that this is the reflexive property. Reflexive property of segment congruence. Nice. Cool. We found our three sides. 1, 2, 3. Now we're given two pairs of angles that are congruent. And we know from what we just talked about that if we know that two sets of angles are congruent, then by the third angles theorem, the third angles have to be congruent as well. So D must be congruent to B by the third angles theorem. What can we conclude? Well, we conclude our proof statement. Triangle ACD is congruent to triangle CAB because all corresponding parts are congruent. And that's a wrap on 5.2. Thank you so much for listening, everybody, and have a fantastic rest of your day.